We are going to continue from where we ended last time with the correction of the following exercise for application. Question 1 says prove that y equal to x minus 3 is a tangent to the curve y equal to x squared minus 5x plus 6 and find the coordinates at the point where the line touches the curve. We know that a line is a tangent to a curve if the line touches the curve at one and only one point. We have to prove that y equal to question 1. We have to prove that y equal to x minus 3. This is the equation of a straight line. Is a tangent to the curve y equal to x squared minus 5x plus 6. We know that at the point where the line touches the curve, the equation of the line will be equal to the equation of the curve. That is, at the point where the line y equal to x minus 3 touches the curve y equal to x squared minus 5x plus 6, we have the line will be equal to the curve. So this will give us x squared minus 5x plus 6 to be equal to x minus 3. So this will give us x squared minus 5x. We are going to transfer x to the left hand side, minus x plus 6. We are going to transfer negative 3 to the left hand side, plus 3 is equal to 0. This will give us x squared minus 6x plus 9 is equal to 0. And this is a quadratic equation. We know that if the line y equal to x minus 3 touches the curve y equal to x squared minus 5x plus 6 at one point, then the discriminant of this our quadratic equation will simply be equal to 0, which is a proof. So we take comparing x squared minus 6x plus 9 equal to 0 with the general form of the quadratic equation ax squared plus bx plus c equal to 0. We have our a to be 1, our b to be negative 6, and our c to be 9. We know the discriminant is given by b squared minus 4ac, and this will simply be equal to negative 6 squared minus 4 times 1 times 9. And this will simply be equal to negative 6 squared gives us 36 minus 4 times 1 remains 4. 4 times 9 is 36. 36 minus 36 is equal to 0. Since the discriminant of x squared minus 6x plus 9 is equal to 0, therefore means the line y equal to x minus 3 is a tangent to the curve y equal to x squared minus 5x plus 6. We conclude therefore y equal to x minus 3 is a tangent to the curve y equal to x squared minus 5x plus 6. The next part of the question says we should find the coordinates at the point where the line touches the curve. For us to find the coordinates, we are simply going to solve the quadratic equation x squared minus 6x plus 9. When we solve this quadratic equation, we are going to get the x coordinate at the point where the line touches the curve. And in this case, we are going to obtain repeated roots. The roots must be repeated since the line touches the curve at one point. Now let's proceed by solving the quadratic equation x squared minus 6x plus 9 equal to 0. Solving x squared minus 6x plus 9 equal to 0. So we need two numbers such that their sum is equal to -6 and their product, the product of the same two numbers, is equal to 9. So if we take -3 plus -3, it gives us -6. -3 times -3 gives us 9. This will simply give us x squared minus here minus 6x plus 9. I will factorize the left hand side to be the same as x squared plus, I will replace -6 with -3 plus -3. -3, we know positive negative will stay, -3 minus 3 in bracket times x plus 9. And this will simply be equal to x squared plus, we expand, -3 times x gives us -3x, -3 times x gives us -3x plus 9, which will simply be equal to x squared, positive negative, we know negative will stay, x squared minus 3x plus 9. If you look at the first pair, x is common, we factor out x. X times x gives us x squared, x times -3 gives us -3x. The second pair, we factor out the -3. -3 times x gives us -3x. -3 times -3 gives us 9. We have two terms, x minus 3 is common, we factor out x minus 3 times x minus 3. This will simply be the same as x minus 3 all this squared. X squared minus 6x plus 9 equal to 0. Then x minus 3 all this squared, because this is a factorization of x squared minus 6x plus 9, it will equal to 0. Which simply means that if we take square root on both sides, let's take the square root, it will simply be equal to the square root of 0. This and this will go off. We'll be left with x minus 3 to be equal to 0. Then our x will simply be equal to 3. You can see we have just one value for x. In this case, the quadratic equation has repeated roots. Now, this value for x equals to 3 is simply our x coordinate. By making use of this value, we can find our y coordinate. For x equal to 3, y will be equal to, we are going to replace it with 3 in any of the equations, whether the equation of the line or the equation of the curve. Remember, the equation of the line is simply y equal to x minus 3. The equation of the curve is simply y equal to x squared minus 5x plus 6. So if you replace it in the equation of the line, this will be equal to 3 minus 3. It's very easy to make use of the equation of the line. You can see in the equation of the line, the degree of x is simply 1. And this will be equal to 0. If in case you decide to make use of the equation of the curve, let's just make use of it. Y will be equal to 3 squared minus 5 times 3 plus 6. This will be equal to 9 minus 5 times 3 is 15 plus 6, which will be equal to 9 minus 15 gives us -6 plus 6, which is 0. You can see the results are the same. We conclude therefore 3, 0, the x coordinate is 3, the y coordinate is 0. 3, 0 is the point where the line touches the curve. Let's underline the point. At this point, the x coordinate is 3, the y coordinate is 0. Question 2 says, for each question, state by working which of the following conditions apply on the straight line to the curve. I, we have a tangent to the curve. 2i cuts the curve at two distinct points. 3i neither cuts nor touches the curve. For A, we have y equal to 3, x squared minus 4x minus 2, and y equal to x minus 3. Remember, this is the curve, this is the line. Okay, question 2. For question A, we have y equal to 3, x squared minus 4x minus 2 for the curve, and the line is y equal to x minus 3. First thing, we know that the point where the line and the curve they intersect or they meet, the line will always be equal to the curve. The equation of the line will always be equal to the equation of the curve. It therefore means if we equate these two, 3x squared minus 4x minus 2 to x minus 3. This will give us 3x squared minus 4x. We transfer x to the left hand side, gives us negative x minus 2. We transfer 3 to the left hand side, gives positive 3. Transfer negative 3 to the left hand side, gives positive 3. Will be equal to 0. This will give us 3x squared. Negative 4x minus x will give us negative 5x. Negative 2 plus 3 gives us positive 1 is equal to 0. At this level, we are going to start by finding the discriminant of this quadratic equation. You know, our A is equal to 3, the equation of x squared. Our B is the equation of x, which is negative 5. And our C is the constant term, which is 1. We know the discriminant is given by b squared minus 4ac. And this will be equal to negative 5 squared minus 4 times a is 3 times c, which is 1. This will give us 25. We know negative 5 squared is 25 minus 4 times 3 gives us 12. 12 times 1 remains 12. We take 25 minus 12 gives us 13, which is greater than 0. Since the discriminant is greater than 0, in this case, the line cuts the curve at two distinct points. So here we conclude that the line y equal to x minus 3 cuts the curve y equal to 3 x squared minus 4x minus 2 at two distinct points. We are done with question A. We go now to question B. It says we have y equal to 7x times x minus 1 and the line y plus 2x plus 1 equal to 0. Let's write it down. We have y equal to 7x times x minus 1. We know that this is the same as 7x squared minus 7x, and the line y plus 2x plus 1 equal to 0. We know y plus 2x plus 1 equal to 0 is the same as y equal to, if we transfer 2x to the right hand side, it becomes negative 2x. We transfer 1 to the right hand side, it becomes negative 1. Next thing, we know at the point where the line and the curve meet, the equation of the line will always be equal to the equation of the curve. So if we equate these two equations, equate 7x squared minus 7x to negative 2x minus 1. This will give us 7x squared minus 7x. We transfer negative 2 to the left hand side, it becomes positive 2x. We transfer negative 1 to the left, it becomes positive, is equal to 0. So this will give us 7x squared minus, we know negative 7x plus 2x is negative 5x. plus 1 is equal to 0. And this is a quadratic equation. The next step, we need to find the discriminant of this quadratic equation. We have 7x squared minus 5x plus 1 is equal to 0. In this case, our A is the equation of x squared, which is 7. Our B is the equation of x, which is negative 5. And our C is the constant term, which is 1. We know the discriminant is given by b squared minus 4ac, which is simply equal to, we take negative 5 squared minus 4 times a, which is 7, times c, which is 1. This will give us, we know negative 5 squared is 25, minus, we take 4 times 7, it gives us 28 times 1, 28. 25 minus 28 gives us negative 3, which is less than 0. You know, when the discriminant is less than 0, it simply means the line does not intersect with the curve. The line and the curve, they don't meet. Therefore, we are going to conclude, therefore, the line y plus 2x plus 1 equal to 0 does not cut or touch, the curve y equal to 7x times x minus 1. And we are done with this one. We go to the next question, which is question C. We have the curve y equal to 9x squared minus 3x plus 10, and the line y equal to 3 times x plus 3. We know this line is simply the same as equation of the line. 3 times x gives 3x plus 3 times 3 gives 9. We expand. Next, we know if the line meets or the line intersects with the curve at those points, the equation of the line will be equal to the equation of the curve. So we equate the two equations. We equate 9x squared minus 3x plus 10 to 3x plus 9. This will give us 9x squared minus 3x. We transfer 3x to the left hand side, minus 3x plus 10. We transfer 9 to the left hand side, minus 9 is equal to 0. This will give us 9x squared. Negative 3x minus 3x gives us negative 6x. 10 minus 9 gives us 1. So plus 1 is equal to 0. The next step, we are going to find the discriminant of this our quadratic equation. You know, a is equal to 9, b is equal to negative 6, and c is equal to 1. We know the discriminant is given by b squared minus 4ac, which is simply equal to negative 6 squared minus 4 times a, which is 9, times c, which is 1. This will give us 36. You know, negative 6 squared is 36, minus 4 times 9 gives us 36, times 1 remains 36. 36 minus 36 is equal to 0. The discriminant being equal to 0, it therefore means the line y equal to 3 times x plus 3 is a tangent to the curve 9x squared minus 3x plus 10. Therefore, the line y equal to 3 times x plus 3 is a tangent to the curve y equal to 9x squared minus 3x plus 10. And we are done with the questions. So if you are given such questions, for you to check whether a line intersects a curve at two distinct points, or a line is a tangent to a curve, or a line does not cut or does not touch a curve, firstly, we need to start by equating the equation of the curve to the equation of the line. After equating the equation of the curve to the equation of the line, you bring all the terms, you transfer all the terms to one side so that you obtain a quadratic equation. After obtaining the quadratic equation, you find the discriminant of that quadratic equation. If the discriminant is greater than 0, then you know the line intersects the curve at two distinct points. If the discriminant is equal to 0, then the line is a tangent to that curve. If the discriminant is less than 0, then the line does not touch or does not intersect with the curve. So that's how we get it. In case you have any worries, you can leave your questions at the comment section. Please, if you like the video, share, and do well to subscribe to this YouTube channel. Thank you very much for watching.